I am so thankful, I have to say, that you're doing this work. I just started working as an assistant professor, and I now spend the majority of my time writing emails. So it's really, really great that someone is working on improving privacy for emails. The time that I don't spend emailing, I spend in meetings. So luckily now we're going to have a talk about end-to-end encrypted calendars delivered by Fernando, who's a lecturer at the University of Surrey. All right, stage is yours, Fernando.
So when you have this kind of recipe, the cryptographic solution or proposed solution is end-to-end encryption. End-to-end encryption, depending on the setting, has seen a quite successful deployment. So if your two ends are the client and the server, we have TLS. If your two ends are people on a messaging app, you have Signal or other variants of the double ratchet. However, for storage, the situation is a bit of a mixed bag. There is one proposal, which is CSS, but published at Crypto 2024, but this is, as far as I know, greatly academic, and otherwise there are about a bunch of proprietary solutions. So, of course, coming from this angle with my hot takes, a natural question is, okay, we have some sort of secure storage solution available, so how usable is it? How does it translate from a paper into an application? And particularly, I need to motivate myself, so how does it improve my life? So of course, my favorite activity, I figure, is checking my calendar, my work calendar. And jokes aside, I essentially don't function as an academic without a very detailed work calendar. I use it for my notes, for my to-do list, essentially. I've been pushing the one for my tax return now for like 6 months, probably. And also, I use it for all my meetings with students. And actually, it's really, you can really see sometimes some connection in the calendar breaks, or like it logs me out, and then I start missing meetings, and then it's just chaos. So it's a really important tool. And interestingly, because I use it for work, but I also use it for personal information, it contains a lot of sensitive information about me. It contains where I am at certain points in time, what kind of stuff I'm up to, who am I seeing. And so it seems like it's a good candidate for trying to protect cryptographically. Now, if you're using an internet calendar, most likely you're using something that supports CALDAV. CALDAV is a specification. It's an evolution of older protocols, proprietary protocols, I believe, by Apple. And essentially, there are two main RFCs that define most of the current functionality. Now, interestingly, if you go to read those RFCs, you're first told read WebDAV, the Web Distributed Authoring and Versioning protocol, which is really just remote storage over HTTP. So this also has like a long and very engaging RFC to read. Now, interestingly, most of these RFCs are just concerned with, okay, a lot of these things you can already do with HTTP. HTTP lets you put, lets you delete, lets you update, and so you're just doing those, and you're just sending binary blobs, or you're encoding in some way. However, the magic sauce here is the fact that if you have a calendar, then it's a little bit more richer functionality, in particular some search functionality that you want to implement. So you can do, say, range queries over what are my appointments today. And there is also a lot of multi-user support because, as you all know, you're able to invite other people. And in corporate settings, you're even able to see, oh, when is this other person busy? And sometimes you get to see what they are doing, and sometimes you just get to see that they're busy. And so you should try not to put an event in there. And so there is this like fake simplicity, let's say, right? Or apparent simplicity, but then a lot of multi-user little details have to be solved. So as an overview of how CALDAV works, very abstract, what you do is you have a server, and in this server you register an account. Usually, commonly an email provider will register an account automatically. And what this account is just a folder that belongs to you. And then you may have one or more calendars that belong to your account. So for example, I might have a work calendar, which this is a subfolder. When I set up a call with someone, I just create a file and I put it into this folder. The file has some structure that is both a mix of like a Windows ini file and an XML all put together or something like that. So it's not particularly nice, but essentially you can think of this as some key value store. And then I might have a second calendar, and in that case I might also have particular events I might be adding. And essentially, as long as I can point directly to my root folder, I can just recover all this other information. So in terms of end-to-end encryption of calendars, in the wild, there are a few providers. This is the picture as of 2024, and I think Proton and Tuta are still in this business, and Skiff and OurCall maybe merged with other companies, and I'm not entirely sure if they are or if they aren't. So I'm not claiming anything more than when I originally looked at this in 2024, that was the situation. So Tomas, which is the one of my co-authors, started looking at Tuta in 2024 for his master thesis. Essentially, the takeaway about Tuta's calendar, which is also the only one we looked at, so I don't vouch for anything else, is that it's been established in 2019. We can tell that from the Git repository. And interestingly, essentially, what Tuta is doing here is CSS. I think this is not. This is essentially happenstance, and it's because it's the really, if you sit down and want to think about how to do encrypted file storage, you would come up with a similar solution. Now, the takeaways for Tuta is that it's mostly, from what we can see, a solid solution with the usual in the wild caveats, meaning that their website implies in vague wording that you have malicious server security, but really the server also operates as a PKI when you're sharing events around, so you have to trust that they give you the right public keys if you want to invite people. And also that files are JSON objects, so they're key value pairs, and they authenticate and encrypt the values, but not the keys, and so you're able to move these around. Now, this is acknowledged by the developers, and it's a one fix. Why would you want to authenticate your keys is the comment. In practice, however, these we could not exploit. As in, for the calendar setting at least, you can make events disappear if you switch, for example, the start date and the end date. But this is the same as the server just not serving you a file, so it's not fundamentally a problem. And so naturally then, when we set out, we looked at Tuta. We said, well, this is just CSS, so let's build it on top of CSS, and let's try to formalize this monster and try to prove something about it. Now, in particular, this is also an interesting maybe testing ground for CSS because it shows, okay, what's there and what's still needed if you want to use this as a tool. So we had to figure out some multi-user and search functionality, which is under-specified, I would say. It's not entirely absent, and the paper comments about it, but doesn't give a specific solution. Something also nice, they tried until very late to get working as a demo, but couldn't, is that we think we can also get out-of-the-box CALDAP compatibility with CALDAP clients by just creating a little local proxy that is a CALDAP server that runs on your machine. You install this one, and then you point your client to this proxy, and then the proxy will do CSS request, translate CALDAP requests into CSS requests to an external server. So there, in terms of, we're trying to think when, like you're doing this job of doing the research and marketing the paper before the paper exists, and so you're thinking, okay, what's the cool demo here? And the cool demo is that you could have an end-to-end encrypted, generically compatible calendar, possibly. Anyway, if you know the meme of the horse that starts very nicely drawn at the beginning and then it's less nicely drawn at the end, that's where we started with our goals. And our current situation is that we identified some of the some blockers in the design. These are all easy to circumvent, and so really we just extend the security model and circumvent these small blockers or under-specified steps. We also outline some strategies for the more advanced functionality that naively would make you think, oh, I want something like multi-party computation, and that in practice maybe you can do if you relax your thread model with simpler objects. And so we're gonna be talking about those shortly, and we're working on implementation, and the paper is also work in progress. So I now move to a little CSS overview because it's quite central to why we make the choices that we make. So in CSS, what you have is you're a user, and you're required to remember your user account and your user password. Morally, I think it makes sense to request this of users and not much more, because if you're doing storage and you want it to be private and you can also keep a lot of state, then you could just keep all your files locally and you're kind of done with your storage solution. And so we're trying to minimize as much as possible the state that the user has to keep. And so when you want to encrypt and store a file, what you have is you're going to have a file F in this case. And I'm going to be writing embraces encryption under a key. So here we have a file F that is encrypted under a file key FK. And this is going to be stored under some file ID, FID, on a server. Now, of course, I'm not keeping file key in memory. So where is file key? Well, I'm going to take file key, and I'll store it encrypted under a master key, also on the server. And this is going to be stored under the file ID and my user account. But now I have to remember a master key. So what do you do with the master key? The master key you encrypt under a key encryption key. You keep this one in the server under your own personal account. There is a little bit more of state that you keep under your personal account, but I'm just showing what's strictly necessary here. Because you're also keeping, in this case, a key, shared key for an OPRF. And then the way that you tie all of this together is that whenever you're trying to fetch a file, you're going to have to first establish a session. And to establish this session, you're going to use your account ID and your password and this OPRF to recover the key encryption key. So you just need to remember your password, and from that you get the key encryption key, from which you get your master key, from which you can get any file keys. And this is what more or less also Tuta does. Tuta doesn't have an oblivious PRF. They have like a more salt and hash solution with some tricks in there that I won't get into. So something that is not specified how to do is left to the application developer is how do you choose the file IDs. I mentioned this because it's going to come down the line in a couple of slides. From the point of view of security, what we have is that CSS, thanks to this sort of modular structure where your password is used just to derive a key encryption key that encrypts a master key, you're allowed to rotate your password without having to rotate your master key, and so without having to re-encrypt anything other than just some of your account data. And so you get something that it's natural to have in this kind of application, which is password updates. And then, of course, you can do in-transit encryption. I bring this up because the CSS paper focuses on a malicious adversary and everything that a malicious server, and everything a malicious server can do, an in-transit or a network adversary can also do. And so rightfully, they decide to abstract that component of the system design away, but it seems like naturally you would just do in-transit encryption. Now, from the point of view of calendars, there are some functionality requirements that are met and some that are not directly met. So you have multi-user support, and we will see how for sharing access to files. It is possible to build a directory structure like the one using CalDAV. However, it's not clear how to do push notifications when someone receives a file. There is no direct support for read and write permissions, and there is also no clear range query support. So in the remaining minutes of this talk, I'm just going to talk about how we propose to solve some of these. And these are just very minor, just application level concerns, but I think could be a guide for how to use CSS also elsewhere possibly. And internally, we're calling this CSS++. And we'll see later if we want to, do this service to the community by adding more, modifiers to names of protocols that already exist. All right, so let's first deal with the security requirements. So I mentioned that in-transit encryption for CSS is possible. Essentially, it's just mentioned, but not a lot of detail is put. And again, this is because the authors were really focusing on malicious servers. Now, the natural initial solution that comes to mind is just TLS encrypt all of this communication, and you're done. And that probably works totally fine. The only complexity is that then you want to prove a theorem about this in a setting where the server may be semi-honest and the network adversary is malicious. So you can show that you achieve more than the ground level security that CSS provides in that setting. And combining TLS with passwords, it's not immediately obvious how to compose and then how to prove a theorem about. So here our solution is to just modify the description of CSS in the authentication establishment as a simple PEG interaction, and then embed it into the construction. This way, then you can use a security model that is a little bit easier to think about. None of this is a shocker. Something else nice, as I mentioned, CSS supports password updates, but it doesn't necessarily specify the algorithm for doing it. And so if you just make this procedure, which is the obvious one, explicit, then you can prove a theorem about this, and you can show that you achieve security also for this specific way of updating passwords. So far, so good. And in terms of security goes, this is all that you need to do. Or at least that's most of what you need to do. So instead, we can go back to the functionality requirements, which are a little bit more fun to play around with. The disclaimer here is that there are many approaches for how to do this. Our philosophy has been to really embrace the storage, file storage aspect. So try to build the calendar as a little thin layer on top of CSS, and try to reason of all the stuff that you want to add as a file, because there is already all the functions for how to deal with files. So don't add complexity by adding a lot of different oracles necessarily. This way, you can keep kind of all the cryptographic operations inside of what CSS already does, and I think it lets you worry less about how you are running your application on top, because the calendar application doesn't need to be handling keys. You just need this. It's all hidden in this CSS core. This means that maybe we over-relied on sharing files and encrypting files, but it just fits this philosophy. Right. I'm aware that I have 2 minutes, but I'm going to take a third one because of the screen blackout. And let's think it's a nice trick, because if you can keep talking during the blackout, you're really just extending by a minute your presentation. So directory trees, this is the first one, and this looks pretty obvious. Your files and your directories should just be JSON, the universally accepted best key value store ever, and absolutely no criticisms about it. And so, for example, what you would like to do, remember, is you don't want the user to have to keep state. So the natural solution that you think of first is, okay, the root account is all they need. So what you will do is you create a file, and this file will have a predictable FID that the user does not have to remember. The application will just derive. And then we're going to have, for example, a work calendar that is going to have some FID. In this case, it's predictable, but it wouldn't need to be. And then my root points to my work calendar, essentially. And then my work calendar points to a bunch of events that are in there. And at first, you write this down, and then, oops. There's a problem with this, and the problem is that there is no guarantee that the root FID is not adversarially taken by another user in the system, because CSS doesn't impose a specific way of choosing file IDs. So I could just, like if the root ID was like that, I could create all my company, all the john.smiths at company.com, and fill all of those root IDs. It's just a silly, trivial to avoid application attack, but it's one of the things that it's interesting to keep in mind. And so the solution for this, if you remember, CSS had this little data for the user, and then there was this account data. And now the trick is just sample at random your FIDs. And in this particular, and this is specific to the fact that we want to store a file tree as our file system inside CSS. So because we just want a file tree, we just need to remember the root ID, the root file ID, and so just store that one encrypted. We call this generically application metadata. We store it encrypted, and it's kind of like, it's like one ciphertext that is lying around. Again, there is nothing cryptographically magical here. It's just having this extra bit of information helps you then bootstrap your application later. All right, for range queries, here is another hot take. What we're going to do is, so far we had this server. This server is keeping encrypted files and encrypted file keys. So we are gonna, for every file, we're gonna collect keywords. In this case, in the case of calendars, it would be start and end dates. It could be other forms of metadata. We're gonna encrypt it under a keyword key, let's say, on the server, and then we're gonna trust a third party. And in the next slide, I'm gonna suggest 3 different models for the party, but this is a search party, which essentially just, we are leaking the search metadata to the search party. We can implement this search party as just another party in the CSS, another user in CSS, and we could just treat these file keywords as a file that we're sharing to them. So this can be done all as part of the existing API. Of course, then who's the third party? Well, one solution, the most horrible one probably, is to just write your cloud provider. So you're essentially giving them all the search metadata, but it's very simple to implement. Another one, the one I'm most excited about, is that you could self-host your search party. So currently, if you figure my home IP address and you hack me, you're going to get all my data in my personal Nextcloud. And instead, this way, you could just get my metadata in my personal Nextcloud, but I'm reducing a little bit the attack surface. Finally, in the case of calendars, realistically, calendars are small enough. The metadata is small enough that you could just treat yourself as a search agent. So just keep a file around that is encrypted and there is an index of where to find things. You upload this one, you have to keep it on disk at all times, and maybe for large deployments wouldn't work, but for small calendars, you can just do this very easily, and you don't have to worry about third parties at all. And if you like more controversy, I'm selling more controversy today, you could even add searchable encryption here, not as the outer layer, God no, but as an inner layer. So what you could think is, okay, I'm gonna do instead of storing keywords, I'm gonna store a searchable encrypted version of keywords. Now, searchable encryption does leak information to the party that gets access to the ciphertext, but essentially what you have here is you're leaking a little bit less than just giving them the keywords. Now, in terms of file sharing, essentially what CSS is doing is that it treats file sharing out of band. If you want to share an event, you could just send that event to a party, or rather send the file key, and the party could decide to accept the file and put a header. This means every time you want to share with someone, you have to communicate with them. And what you can do instead, and I'm going to add a little bit of read-write access, is when you create a file, create also a pair of signing verification and signing keys. Add them to the file header encrypted. Add the verification key to the file. And then what this lets you do is that if you wanted to share a file, you can decide to share the signing key with the receiver, and then they become a full owner of this file. Or you could decide to just share the verification key with the receiver so that they cannot modify this file. In the sense that if they did and they pushed it, the server would get ciphertext, would know the file verification key for this file, which is trusted on first use, and would check if the addbase is legitimate or not. And then when we go back to the file sharing, have users which were out of bounds generate encryption and signature keys. They can share their public and their verification keys out of band, and they do this only once when they start collaborating. And then if I want to share, rather than talking to the person, I can just talk to the server, send a public key encryption of my file keys, essentially, and the file ID. And whenever the receiver comes online, they receive this information. And they can decide to accept or not this file. This means that you have less out-of-bounds contact, and also that you can decide to invite someone without letting them change your events. And the reason this matters is because this enables you to do these accept, tentative, and reject options in calendars. The way this would work essentially is that if I'm organizing and I have three people I want to invite, I will create a file that I will share with all of these people in read mode, which is a file where they can mark their attendance. So essentially, and then I create another file, which is the event, and the event is going to point out to these RSVP files. And then I share everything in read mode with everybody except if I'm inviting Kien and I want Kien to be able to RSVP, the response for Kien is gonna also have the signing keys for that file, so they're gonna be able to modify that one and only that one while seeing the state of everybody else. All right, in conclusion, I'm a little bit over, but essentially we identified that calendars have a lot of interesting data and that it's also requires a bunch of non-trivial file sharing functionality, so it seems natural to attempt instantiating it for CSS. We propose a bunch of small tweaks. This is a non-exhaustive list because we haven't gotten into showing your availability and such. And that's all I have for you today. Thank you.
Thanks a lot for the great talk, Fernando. We're a little bit over time, so I think we'll head straight into the next talk, but do find Fernando in the breaks if you have any questions.